Without further ado, I'm just going to introduce the first speaker of the day. And even though she doesn't need any kind of introduction, I'm just going to say that she's a world-class accessibility expert, Leonie Watson. This is actually a quote from her website. I strongly encourage you to be bold and design and code like you do. You give a damn. You actually give a damn. Welcome, Leonie. Woohoo!
Okay, are we good to go? Great. Good morning. Kalimera. My name is Leonie Watson, and this morning I would like to talk to you about accessibility. It's something very close to my heart, partly because I'm blind, and so I need things to be accessible in order for me to be able to use them. But it's also important to me because, as Simone mentioned, to me, it's about designing like we give a damn. Like we give a damn about the things that we're building, like we give a damn about the people that we want to use the things that we create. I also recognize that accessibility isn't always the most exciting topic to listen to a talk on. So I'm going to try and perhaps inspire you a little more to think about accessibility, even when it's difficult, when you're up against a deadline, when you have a client or a project manager who doesn't think accessibility is important. You'd be surprised what you can accomplish if you really try. So to do that, I'm going to use a piece of music that comes from the late 90s and the house dance music scene by a group called Daft Punk, and the piece of music is Technologic from the album Human Afterall.
Buy it, use it, break it, fix it.
So buy it, use it, break it, fix it. I think this is how people see accessibility a lot of the time. Do we buy it into our team? Do we have to bring in an agency or a third party to work with? If we try it ourselves, are we going to break it? Are we going to get it wrong? Is that going to be a big problem? Or, perhaps, can we fix it? There is no easy answer to that, but what I'd like to encourage you all to do is try fixing it.
Trash it, change it, melt, upgrade it.
So upgrade it is an important philosophy when it comes to accessibility. And the simple reason is that when you use HTML, you get a lot of accessibility for free. You don't have to do anything. So, for example, when you use an HTML element, the browser knows what that element does. So, for example, a heading element, the browser knows that it represents a heading. It'll give you some default styling if you want, but it'll also make accessibility information available about that element. So someone who uses a screen reader like I do can find a heading on a page and know what it is. If you haven't come across a screen reader, it's a piece of software that translates what most people on screen into synthetic speech, and I'll show you how some of this works. If we take this really simple HTML link, it's just an anchor link with an href that points to the source, and inside it some text. If we look for the accessibility information about this link, we'll find that the browser says it has a role of link, so my screen reader knows it's a link. It has an accessible name of TinkUK, that's the text inside the anchor link. And this is how a screen reader sounds when it finds this piece of code.
Tink.uk link.
So it says tink.uk, the text that everybody sees on screen, and then it tells me that it's a link. That's all just picked up from the HTML. In the same way, if we take a very simple image, this time with an alt attribute that gives this an accessible name that describes the image, the browser tells my screen reader that this thing has a role of image. And so my screen reader says this.
Graphic, a bottle of Chamuco's tequila with the dancing devil logo.
It tells me it's a graphic, and it reads out the alt text. So if the alt text is present, I know what this image describes. It works with all kinds of elements. So in this case, we've got a standard input that's a type of checkbox. It's got the checked attribute set on it. This time, the role is checkbox. That's from the type attribute on the input. The accessible name this time comes from the label element, because the text inside the label element is associated with the input. So this is what my screen reader will tell me.
Tequila checkbox checked.
So it tells me it's a checkbox, that it's already checked, and it tells me that this checkbox will let me select tequila. Never a bad thing, of course. You have to be aware, though, that there are two elements that have what we call neutral semantics. In the browser, they don't convey any accessibility information at all. Divs and spans. So if you use a div or a span, nothing is informed my screen reader about it. Anything inside the div or the span just appears like plain text. And this is really important to remember because, of course, we use these two elements every day to create custom widgets, custom components. We even use them sometimes to recreate elements that we've got in HTML, perhaps because that's how the JavaScript framework we use operates, or perhaps we want to create something that doesn't exist in HTML, like a set of tab panels, for example.
Chart it, point it, zoom it, press it.
So a press it, this is the thing to remember here. The browser does a lot more besides, in terms of accessibility, than just give you information about the role and the state and the accessible name of an element. Everything in HTML that is defined as an interactive component can be focused on with the keyboard. So if you have a link or a button or a form field like an input or a select, the browser lets you focus on it with a keyboard. Some people who use a keyboard will use the tab key to navigate from one focusable element on the page to the next. So if you don't use a mouse, keyboard focus is incredibly important. So when you code something and you put the code together and the browser creates the document object model, the DOM, the order that your elements appear in the DOM is the order that someone will focus on them with the keyboard using the tab key. So in this quick example, we've just got 3 buttons on screen, 1, 2, and 3, and they fall straight after each other in the DOM. Sorry, there we go. So if we look at this in terms of how a keyboard user will focus on them, this is the sequence. So it just literally goes as the code, 1, 2, and 3, as simple as that. Another thing that the browser provides for you is expected interactions. Again, if you use a keyboard, you need to be able to activate things like links, buttons, form fields, and the browser provides all this behavior for free. You can activate a link with an enter key, a button with the enter or space keys, and you can enter form fields to interact with them, again, using the enter key. All of this, of course, is automatically supported on touch devices by the browsers on those platforms as well. So the really great thing about HTML is if you use it where you can, the browser will do a lot of the heavy lifting for you.
Quick erase it.
So how does it all work in terms of the browser? What's actually going on under the hood that does all this hard work for you? If we take another piece of HTML code, again, a pretty simple checkbox with a label, this time for a bold form field, this is what happens in the browser. When it loads the document, it creates the DOM tree. This is the bit, of course, that we all interact with JavaScript to create behavior and functionality and interaction on our websites. The browser also creates something called an accessibility tree. It takes a lot of the information from the DOM and recreates another tree architecture, but this time it only contains accessibility information. So a node in the DOM has a corresponding node in the accessibility tree, but in the accessibility tree, the information that you'll find out is what's that element's role, what's its accessible name if it has one, what state is it in if state is important to that particular element. And so it works on a sequence like this. The browser passes the code and creates the DOM. It then takes information from the DOM and creates the accessibility tree. Whenever the DOM gets updated, perhaps because we've scripted it to change, maybe a push notification, or it changes based on user interaction, part or all of the DOM gets rebuilt, part or all of the accessibility tree gets rebuilt, and then that fires an event, and assistive technologies like screen readers are listening for those change events, and they then understand what has changed in the page and can convey that information to someone like myself who can't see the page, maybe hasn't seen that push notification appear on the screen. The way they do this is through accessibility APIs. These actually exist at the operating system level, and they're available on every OS. Windows actually has 3, UI Automation, MSAA, and iAccessible 2, but they're also available on macOS, on iOS, on Android, and Linux platforms. And these APIs, unfortunately, are not JavaScript APIs. We can't use them as developers, but assistive technology companies, so screen readers, can use these APIs. And they use these APIs to query for information about objects on the screen. So in other words, they use these APIs to access the information that's available in the browser's accessibility tree to find out what a thing is and what it does.
Write it, cut it, paste it, save it.
So I mentioned earlier that there were a couple of elements that don't have any accessibility information available to them, divs and spans. What can we do to save that in terms of accessibility information? As developers, we need to use those elements. That's pretty much a truth of web development in today's age. The answer comes in the form of a technology called Aria. It stands for Accessible Rich Internet Applications. And it's a set of attributes that can be applied to HTML or SVG if you're using that. And they polyfill the accessibility information for the benefit of screen readers. It's really important to remember that Aria is really only useful to someone using a screen reader. It's not a complete accessibility solution. It has a very specific purpose, and that's to provide accessibility information for the benefit of people like me who can't see what's going on the screen. So it has a number of roles that are used with the role attribute, and we can use this attribute with any number of different values to provide that information to a screen reader user. There are roles for tab lists, for tabs, for sliders, for dialogues, for progress bars, menu bars, toolbars, and in fact, many of the components that you typically find in software and increasingly in recent years in web applications. It also has ways that you can provide the accessible name for an element and also some longer information called the accessible description. So the Aria label attribute or Aria labeled by or the Aria described by attribute let you fill in more of the information that a screen reader user needs to know. There are also attributes that let you communicate the state of an element. So Aria pressed for when a button is pressed. Aria expanded for when something like a disclosure widget is open or closed on screen. Aria invalid for when a form field has returned an error that needs to be fixed. All of these are communicated to screen readers just by querying that API and adapting the accessibility information that's in the accessibility tree using these attributes.
Load it, check it, quick rewrite it.
So rewrite it. How do we put some of this into practice? I'm going to take a disclosure design pattern. The URL on screen will take you to the actual code if you're curious about it. We could start with some much better HTML than this, but this is a worst-case scenario. So we're going to start with a span that's going to provide the control for the disclosure widget, and then a div that just holds the content that's going to be shown or hidden. This is what happens when you try and use that HTML code with a keyboard. Nothing. Because you can't focus on a span. It's not an interactive element, so the browser doesn't provide any focus. If you can't focus on it with a keyboard, you can't interact with it using a keyboard either. So we need to do some repair work to make this more accessible. The first thing we can do is add in focus. We can make the span element focusable by using the tab index attribute. And we give it, in this case, a value of 0. 0 just adds an element to the tab sequence based on where the element appears in the DOM. So it's a very natural way to make something keyboard focusable. If you need to use the tab index attribute, 0 is almost always the best value to use. And we'll come back to this a little later and see why some of the other values are not quite as useful. We're going to add some accessibility information using Aria. I mentioned the role attribute. This time, we're going to use it with the button value. And in the accessibility tree, this span is now going to be shown as having a role of button. So that's what my screen reader is going to pick up on and tell me that this particular control is. We're going to use the Aria expanded attribute, again, on the span that's the button. And initially, it's going to be set to false, because The disclosure widget will be closed when someone first comes to it. Later on, we'll toggle this value to true, and this will tell my screen reader whether this disclosure widget is open, expanded, or whether it's collapsed. So again, communicating information that's obvious visually, but not to me because I can't see the page. We're going to use another attribute, aria-controls, and this creates a relationship between the button and the div that controls the content or holds the content. When you click on this and you can see that some content has been displayed, it all makes sense. But when I activate this button, there's nothing to tell me that some content has really appeared or where that content is on the page. In this case, it's a disclosure widget, and the content's going to appear pretty close to the button. But this might be used, for example, the button might be used to change some filters on a search results page, in which case the piece of content that's changed could be a long, long way from the button, and it might be really difficult to find if you don't know what you're looking for. So controls takes the ID reference of the div that holds the content, and when the button is used, it makes a shortcut available to my screen reader that will let me move from the button to the content that's just been shown on the screen. Sadly, only one screen reader supports this particular attribute at the moment. It's the JAWS screen reader on Windows. It's a real shame because it's incredibly useful, and I keep hoping that more screen readers out there will start to support this. But for now, it's just the one screen reader. But it's still very worthwhile in terms of the usability that it adds to this design pattern. We're going to put an Aria hidden attribute. We've just got a little inner span that contains a visual icon, just the typical arrows that show whether something is expanded or collapsed. It's purely a visual gesture, though, so I don't need to know about it as a screen reader user. So we'll put aria-hidden equals true on that span. And what that does is it takes that span and its contents out of the accessibility tree entirely. So it'll stay visible on page for people who are looking at the content, but as far as a screen reader user goes, it's not there. It's just vanished completely. It doesn't exist anymore. Lastly, we're going to put the hidden attribute on the div containing the content to be disclosed, because in the first place, we don't want that content to be shown on screen. We could have used any number of different methods here. Display none will hide things visually and from screen reader users. The hidden attribute in HTML will do exactly the same. Just so happens that in this case, I've used the HTML hidden attribute, but equally, the CSS display none is a perfectly good choice to use. Sorry. So the render code we end up with on the page, this is what the browser will render, looks something like that. We've got a span and a div, and the span has all the accessibility information, the role, the state in Aria expanded, and it'll have the Aria controls to set up the relationship between the two. And at first, that div content is hidden away. Lastly, we just need to make it all work. We need to add some mouse functionality, of course, so when someone clicks on that span, the disclosure widget either opens or closes. We also need to add in some keyboard functionality. And in this case, because the span is going to be a button, we need to make sure that people can use it with the space or the enter key. And so we just listen out for the two key codes on the key down event, 13 or 32. And when either of those is detected, we cause the disclosure widget to start working. Browsers on mobile devices will just take care of business automatically for you. So with a simple pattern like this, there's nothing much we need to do in terms of touch support. Lastly, we've got to add the functionality. So when someone activates the disclosure widget, we set the Aria expanded attribute to say true to indicate that the thing is now open on the screen. And we remove the hidden attribute so that the content is actually visible and present on screen for everybody as well. And of course, when someone closes the widget, we reverse that process. So now, this is what it sounds like with a screen reader.
Tequila button collapsed. Enter. Tequila black up pointing triangle button. Use JAWS key plus Alt plus M to move to controlled element expanded. Move to controlled element. Makes me happy.
So now our tequila button works, which is even better than it was before. You might have heard in there that actually this screen reader did announce that visual icon that should have been hidden away. This, unfortunately, is down to a bug with Firefox. It doesn't like the Aria hidden attribute when it's inside a span. If we'd actually been using an HTML button element, it would have worked as expected. But that is just a little Firefox bug, so it's nothing to worry about. Having said all of this, the really important thing to remember is that actually we could have accomplished all of this using HTML and a lot less work and a lot less code. This is a simple design pattern, and by a quick guess, it takes about 20% less code if you use the HTML elements in the first place than it does to add in all this accessibility. Now, that isn't always possible. We could have used the details and summary elements in HTML5, for example, but they're not particularly well accessibility supported. They have reasonable browser support now, but just because a browser supports an element in terms of the way it works doesn't mean to say they support it in accessibility terms. If you're curious about how well browsers do in accessibility support, go to html5accessibility.com and you'll find some really useful information there. But if you can use HTML, do it, because you'll save yourself a lot of time and effort.
Like it, play it, burn it, rip it.
So in terms of testing, it's all very well knowing how to code some of this stuff, but how do you know that you're getting it right? What can you do as developers in particular to test your accessibility? The good news is there are a number of tools that you can use to plug straight into your build processes. The one I really like to use is tenon.api. If you go to tenon.io, you'll find it. It's a tool that's written by an accessibility developer who's a good friend and colleague of mine, Carl Groves. And you can use it in all sorts of different ways. You can even use the API directly to wrap it into your build processes. In terms of installation, you can use it from the web. There is a web interface. There are also modules available, so if you happen to use common tools like Grunt or Gulp, there are ready-made modules that you can plug in. But as I said, you can use the API directly in whichever way you need. And it's a really simple system. You just have two required parameters, your key to connect this to your Tenon account, and the URL that you want to test. And the nice thing about Tenon and other tools like it is that they actually test things using a headless browser. So that means that what they test is actually a very, very accurate equivalent of what a screen reader or other assistive technology will be accessing in the browser. And that's really important because of that relationship between the DOM tree and the accessibility tree in the browser. You can also configure Tenon as well to do a whole lot of different things. You can choose which guidelines you want it to test against. The web content accessibility guidelines are very popular. If you work with clients in the United States, then the Section 508 guidelines are possibly the choice for you. You can get it to prioritize different types of issue. So if you want to focus your testing on a particular kind or area of the site or accessibility, you can do that. It will also return a certainty level. A lot of accessibility is quite subjective. You have to judge it for yourself. With Tenon, what you can do is say, only return the issues you're 100% sure are accessibility issues, or 50%, or whatever other level you want. The last thing I really like about this tool is that you can use it to test responsive sites as well. So you can get it to trigger a breakpoint and do the accessibility testing on that particular responsive version of the site. So it makes testing responsive sites for accessibility much easier as well.
Drag it, drop it, zip and zip it.
So it's not just that one tool. There are lots of tools you can use if you happen to be working with different frameworks and stacks. So, for example, there is a test suite available on GitHub if you use the Ember framework. The Ember community is actually working really hard on accessibility at the moment. They are aiming to have all their standard Ember components be completely accessible. So actually, it takes even more of the hard work out of accessibility for developers than perhaps many other frameworks do. If you use React, there is a test suite, again, available on GitHub. But Facebook has also made the React Accessibility API available. So that's an API you can use in conjunction with the React framework to add in a lot of the accessibility information directly. So you can add role and accessible name and accessible description and state and other information like that directly into your app. Lastly, if you're using Angular, particularly older versions of Angular, there's a module known as ng Aria. And this makes it a lot easier to drop in some accessibility information using Aria. So roles, states, tab index as well. For those of you who do use Angular, you'll be aware of this, but it's really hard to find the place in the code where the accessibility information needs to go. And this module makes it much easier. More recent versions of Angular are doing better in terms of accessibility, so that's another one to watch in terms of good things that are happening.
Lock it, fill it, call it, find it.
So the last thing to remember in terms of testing is that you can do quite a lot yourself. Unplug your mouse and try the things you build with a keyboard. If you can't use them with a keyboard, then that's something you should really go and fix pretty quickly if you can. If you use any platform now, you have a built-in screen reader. So if you have an iOS device, triple-click your home button to turn the screen reader on and off. Android also has a screen reader built in. If you use a Mac, then you can turn VoiceOver on and off the screen reader there. Windows has a narrator, and Linux has a screen reader called Orca. They all also have tools that let you magnify the screen. So for people who are partially sighted or don't see very well, they zoom in so everything's huge on screen. These are things you can try. You might not want to make big decisions based on the experience that you have, because people who rely on those technologies use them every day, and they're going to be better at it than you are. But have a go, experience something, and just start to get an understanding of what it's like to use the products that you're building when you can't see them, or you can't see them unless they're zoomed in, or you can't use your mouse.
View it, code it, jump and lock it.
So I'm going to change tack now slightly and talk a little bit about CSS. Who remembers the Space Jam movie from about 21 years ago? Oh, so people other than me willing to show how old you are. This is good news. So, okay, why am I talking about a film that came out in 1996? Well, the answer is the website. Because believe it or not, the Space Jam website is still up. You can go and look at it, and this is what it looks like. It's got this wonderful kind of star circle pattern going on. And the amazing thing is not just that it's still up there alive on the web after 20-odd years, but it's actually still pretty usable. You need to look under the code, though, to really get a sense of what it's like. This is in the days before CSS. So all the styling was actually in the HTML code itself. We had things like visited link colors, background colors, or background images in this case to create the star field effect. All of this crammed into the body element. It gets worse, I'm afraid. Formatting was using things like the center element in HTML and the no break to stop things wrapping. So yes, everything was a uniform kind of layout, and that was that. We used tables to control layout. That's how they got the circular pattern. Each of those sort of segments of the circle, the star field, is in a separate table cell. Everything absolutely rigid, held into place to the very last pixel. Even fonts were determined in the HTML. We had a font element that let us determine the size, or if we wanted, the color and other characteristics about the font. So everything was put together in the HTML.
Surf it, scroll it, pose it, click it.
So in terms of, surfing it, scrolling it, changing it, clicking it, in terms, you got what you were given. There's no flexibility. There was no concept of anything being responsive, pretty much because everybody looked at things on 17 or 15-inch monitors, and that was all anybody had. You couldn't override the styles if you were maybe colorblind and couldn't see things properly, because it was all hard-coded into the HTML. And although that worked tremendously well in some ways, it wasn't really a good thing in terms of design development or accessibility. Then along came CSS1, just a little bit later, actually, that year. And we started the process of separating the HTML from our design in CSS. And in CSS1, we got the ability to style links and to start using floats. So we started the very early steps of moving away from table-based layouts. And we were on our way to separating out the two things. So we had HTML for information and structure, and CSS to make things look good.
Cross it, crack it, switch, update it.
In terms of updating it, of course, CSS2 and 2.1 came along not long after that. And one thing that they introduced that was particularly interesting for accessibility were the before and after pseudo elements. So for the first time, we had the ability to add content not using HTML, but using CSS. And this was a really big change when it happened. So if we take an example here, we've just got a link that just has the text tequila in it, and then some CSS using the after selector that just adds a little bit more text to complete the phrase tequila makes me happy. It's pretty simple. So this is the render code. This is what will get represented in the DOM, just the link with its original tequila link text, nothing else. And remember, it's the DOM that the browser uses to create the accessibility tree and to convey information to screen readers and other assistive technologies.
Name it, read it, tune it, print it.
So in terms of print it, this is what the CSS specification says about CSS-generated content. It says it doesn't affect the document tree. It doesn't get passed in the same way that other content in the DOM does. So it's looking pretty much like all the DOM is going to see is that original link, and it's not going to pay any attention to the CSS. Or maybe.
Tab, tequila, makes me happy, link.
It turns out that the after content is, in fact, available to assistive technologies like a screen reader. In fact, all browsers do pretty well at this, except for Internet Explorer. So all of the, yeah, I know, all of the modern browsers, the ones that we're increasingly using and moving towards today in the case of Edge, and the popular ones in terms of Safari and Chrome and Firefox, they all detect that extra information and make it available. They do it by cheating a little bit, it has to be said, because that content doesn't appear in the DOM, and so it doesn't get picked up automatically and put in the accessibility tree. But what these browsers do is they create fake nodes in the accessibility tree. They recognize that that content exists, recognize that a screen reader user needs to know about it, and they fake it, basically. They add that information for us. So the good news is that for screen reader users, at least, if you use the before and after pseudo selectors, that content is going to be available to them in most browsers.
Scan it, send it, fax, rename it.
In terms of, not so much rename it perhaps, but reorder it, we've got some interesting things happening in CSS now, one of them being the Flexbox module. Others like it, of course, including the grid layout that are really coming out now and starting to be used a great deal. They offer us huge amounts of flexibility in terms of the way we lay out and arrange information on screen. Flexbox in particular means we can get rid of the old float hacks, which has got to be a good thing by anybody's definition. But there are some things to think about in terms of accessibility. So if we go back to our basic buttons example with our 1, 2, 3 buttons that you remember from earlier in the talk, we have a very simple keyboard order, exactly like it was before. But then, if we start using Flexbox, so display flex and the order property to rearrange the flex order of these elements, we can rearrange them so that on screen they appear in reverse order, 3, 2, 1. The problem is that when you use a keyboard, you'll remember that keyboard users and the tab key rely on the DOM order, not the flex order. So this is what happens. Everything kind of goes back to front. And okay, this is just a very simple demo with 3 buttons in, so it's maybe not too terrible. But if you were arranging the whole of a web application interface using Flexbox, you could really make it difficult for someone who was sighted but had to use a keyboard to know where the tab key was going to take them next. It would be very, very difficult to navigate the screen.
Touch it, bring it, pay it, watch it.
So in terms of watching it, watching where that focus goes, are there ways that we can fix this in Flexbox? Well, the specification has this advice. It says don't use Flexbox if the order that you need to navigate content in is meaningful, which isn't really very helpful at all. We've just had possibly the single most useful thing in CSS for a long time in terms of helping make development and design easier. And the spec says basically, don't use it for half the things that you want to use. Well, that's never really going to work in the real world. So are there any other solutions that we can try and put in place? I mentioned the tab index attribute earlier in terms of making things focusable. We could try using the tab index attribute, so we could set the tab index to use positive numbers. Now, you need to use positive numbers with tab index very, very carefully, because what you're effectively doing is taking control of the tab sequence. You're overwriting what the browser wants to do by default, and when you take responsibility for something, you really have to take responsibility for it. It means you've got to remember the order that you're trying to put in place in terms of the tab sequence. And if you change the interface, if you rearrange things, you've got to go back and make sure that your tab index rearranges things in the right order too. But this is the effect it has in this particular example. It does actually seem to do the trick. We have the keyboard order happening in the same order that things appear visually on screen. Again, this is fine for this simple use case, but it wouldn't work in production out there on a real website, because when you give something a tab index of 1, it becomes the first focusable thing on the page. When you give it tab index 2, it becomes the second focusable thing on the page. So if we were to take these 3 buttons and put them in the middle of a website or a web application containing lots more controls and components, it doesn't matter how many other things you could focus on that page, that button would always be the first. So then we find ourselves in a situation where we not only have to control the tab index or the tab order for those 3 buttons, but also every other focusable thing on the page. And you can see quite quickly then how much extra work and effort it's putting in on the part of you guys as developers, but also the potential for confusion for users. So the simple rule of thumb is that elements with a tab index of 0 are generally a good idea. They're the best way to do it. You can also give something a tab index of -1. That removes it completely from the tab index, so you can't reach it at all with a keyboard, but you can still focus on it or move focus to it with scripting. And generally speaking, a tab index with a positive number is never a good idea. And if you can remember that, that's probably the best way to think about the tab index attribute. There's another possibility. There's Aria-flow2. This is an attribute designed to help screen reader users navigate things in a different order. So again, we could use the Aria-flow2 attribute to match the order of the order properties on our 3 buttons. This is what happens when you use these 3 buttons now with a screen reader.
3 button has flows 2. 2 button has flows 2. 1 button has flows 2.
So on one hand, it seems to work. We're getting the buttons in the same order that they appear visually. But you're being told now that button 3 has flows 2. Button 2 has flows 2. And to use the flow 2 navigation as a screen reader user, you've got to use a completely different keystroke. So you can't use the tab key anymore. In some screen readers, you can use the semicolon. It differs in all screen readers. So we've also introduced another problem. We have now the DOM order for keyboard users who don't use a screen reader. We have the visual order for people who can see the flexed design. And now we've introduced another one just for screen reader users. It's way too confusing. It's too confusing as developers. It's too confusing as users. And so, unfortunately, that's really not a viable solution either. There is something interesting, though. Firefox has a bug. They have to call it a bug because it does something that disagrees with what the CSS Flexbox specification says should happen. If you use the display flex and the order properties in Firefox without tab index, without Aria, or any other fix for the keyboard disconnect, this is what happens. Firefox does something really, really smart. When it detects the order property, it rearranges the tab sequence for keyboard users automatically. So you don't have to think about it from a development point of view. People don't have to think about it from a user or usability point of view. The browser goes back to doing what browsers really do best, and that's doing the hard work for us. I'm really hopeful that other browsers will pick up on this behavior, because it seems to me that universally it's the simplest solution, even though, technically speaking, it is called a bug. But this is very much a space to watch out for in terms of how we rearrange code and objects on screen using Flexbox or grid layout or any of these other new CSS modules.
Turn it, leave it, stop, format it.
So if you've got to this point and the only thought in your head is, let's format it, this is way too complicated, I can't possibly do all of this, there's too much to think about, I'd encourage you to remember that you've already done the difficult bit. How many of you have friends and family, when you get asked what you do, you're just going to say, oh, something to do with websites, the internet. And they kind of look at you wide-eyed because they don't really understand what it means to build technologies, to work with browsers and designs and other technologies. You've already done the hard work in learning how to code. Anybody who survived doing cross-browser design CSS compatibility of a few years ago, if you've survived that, you can survive accessibility. You've done the smart work already. Accessibility is just making it a little bit better because we give a damn about the things that we're building and the people we're building them for. But more than anything, just remember, accessibility doesn't have to be perfect. It just has to be a little bit better than yesterday. If we can all go out and fix one, maybe two things today, maybe another couple next week when we get back to work, maybe another one or two the week after that, pretty soon, we'll all start making a hell of a difference to all sorts of people across the world who need a little bit more accessibility. And so, just think, when you're thinking about accessibility when you get back to work and you don't know where to start, remember this song, because we are human artists, so this is how it goes.
Buy it, use it, break it, fix it, trash it, change it, melt, upgrade it, charge it, point it, zoom it, press it, snap it, work it, quick erase it, write it, cut it, paste it, save it, load it, check it, quick rewrite it, plug it, play it, burn it, rip it, drag it, drop it, zip, unzip it, lock it, fill it, call it, find it, view it, code it, jump and lock it, surf it, scroll it, pose it, click it, cross it, crack it, switch, update it, name it, read it, tune it, print it, scan it, send it, fax, rename it, touch it, bring it, pay it, watch it, turn it, leave it, stop, format it. Technologic. Technologic.
Because it is just Technologic, but most of all, we're human after all. Thank you.
Thank you, Leonie.
Thanks.
Can you guys hear me? Yeah, so thank you so much. Do we have any questions from the audience? Yeah, so we have a question there. Maybe can we get some help?
Hi, Leonie, what a wonderful presentation. That was fantastic. Can I ask you a question though? Shouldn't we, you showed us how to basically take our existing website or platform or whatever and adapt it so that it's accessible. Shouldn't we build for accessibility instead? So I'm thinking, because I am working for a job search engine, we have, you know, millions of users per month, and I'm very ashamed to admit that I haven't done too much on the accessibility front. Now, if this becomes an issue, shouldn't I perhaps, instead of trying to modify my existing code base, shouldn't I find the time and persuade, you know, everyone involved to create something that's specific for people with special needs?
It's an interesting question. The danger with doing that is that it does take extra time, and that takes extra money, and often the specific website falls out of date. So changes are made to the primary website and not to the alternative. And so through the best of intentions, what you end up with is a website that feels a little bit second class to the people who have to use it. So actually you can get a lot further on a lot less money and time if you can make one website that's usable by most people than by creating two or maybe more separate websites. In the future, we may have the ability for personalization to change that, where we still, as developers, create a single website, but as consumers, as users, we can choose how we want to consume that website. I think that looks a lot more possible, but right now, experience suggests that if we try creating specific websites for people with disabilities, we're trying to do the right thing, but we end up making things more difficult and probably worse for the people we're trying to help.
Thank you. We have another question there, please.
So, I have another question. It seems that the Wcag guidelines is really helpful in terms of having a website. But what happens when we have rich web applications? And nowadays we have designers who usually design this rich web application, and then the developers try to implement them. Many of the designers are not designing having in mind accessibility, not even keyboard navigation. So in many cases, we end up with the problem, okay, we have a perfect design, we're implementing it, keeping in mind the accessibility and all that the guidelines suggest, but it doesn't work. So how do we train designers and people involved in the website so that we can actually build one site, following up Angelos' question, but also addressing all of these complications in the web-rich applications?
Part of the solution is in collaboration. So having the designers and the developers spend at least part of their time working together, that really does help. In terms of the guidelines that you mentioned, if you search for WCAG role breakdown, the W3C has produced a breakdown of the web content accessibility guidelines by roles. So it shows you which ones you need to think about if you're a creative designer, an interaction designer, even a search engine optimization specialist, or a front-end developer or a back-end developer. And it's a really useful checklist to help different people in different roles through the production lifecycle know where their responsibilities lie and what they have to think about.
Thank you. We have time for one more question.
Hello. I would like to ask a more practical question. How would you go to create, for example, a website for a stock exchange where you would have values that would change every second?
There is an Aria technique you can use. It's called an Aria live region. The attribute is Aria-live. So where you have, say, your div that contains the stock price that's changing, you can make that container into a live region. And what that means is that whenever the content inside the live region updates, a screen reader will announce it automatically. And you can give it one of two values. You can have Aria live equals polite, or Aria live equals assertive. And when it's set to polite, the screen reader will finish doing whatever it's doing currently and then announce the change. When it's set to assertive, it'll just announce the change straight away. If you have a page with a lot of information that's changing really quickly, that's probably not going to be a good experience because all the screen reader user will hear is price changes, price changes, price changes. At that point, this is probably one of the most difficult things to find a way to make accessible in a way that's also usable. We can make it technically accessible, but we can also just create a very bad usable experience for screen reader users. My company that I work with, we do work with a lot of trading companies, and I must admit this isn't a problem we've yet been able to solve in a really elegant fashion. The best way we've been able to do it is just to offer a very simple view of the information, perhaps in a table format, that maybe focuses in on one particular set of stocks, and so it's more manageable for the screen reader user to hear the updates for one set of stocks as the kind of trading changes the value. we haven't yet found a way to scale that up to a page that contains maybe 20 or 30 different stock items and constantly updating information, I'm afraid. Sorry, but if you think of anything, let me know.
Thank you. Thank you, Leonie.
Thank you. I've had it so.